The variance is a really important statistic, but it's most important because it's what we need to do to calculate the standard deviation later. So let's evaluate what we're trying to get at when we calculate the variance. What we want is a measure of dispersion. We want to know how far away are all of our values from the mean. Are our values all close to the mean, like they are here, where there's a lot of deviations, but none of them are too far away? Or do we have data that looks like this, where the mean is the same, the mean didn't change, but now the spread of the data is much wider. All the observations got further apart from the mean. And so when the dispersion is very small, that tells us the mean really represents a typical case. If the dispersion is very wide, then we know that most observations are pretty far away from the typical case. And so variance is a good way of understanding the differences between observations. So how would we calculate that? Well, we could try to just take the differences between each observation and the mean. If we did that and took each observation and subtracted the mean, then we would end up with some positive values and some negative values. And actually, by the definition of the mean, we know that if we add those together, they're going to equal 0. That's what the mean is. It's the best guess because it's correct on average. The error, which is this difference between our observation and the mean, adds up to 0. So we need something else. We need a way of calculating this dispersion where we're only going to end up with positive values. And so that's one of the reasons why when we calculate the variance, we square that difference. So you can see in our calculation of the variance, we take the difference between each observation and x bar and we square it. Then we add it up for each observation and we divide by n minus 1, or multiply by 1 over n minus 1 in order to average it out. So n would be the number of numbers in our data set. So let's do an example of that calculation. A nice simple one with only 4 values. So x has the values 2, 4, 6, and 8. If you take the average of 2, 4, 6, and 8, you will get 5. So our first step in calculating the variance is to subtract the mean from each observation. The mean is 5, 2 minus 5 is negative 3, 4 minus 5 is negative 1, 6 minus 5 is 1, and 8 minus 5 is 3. Then we square those differences. So we take each of those differences and we square them. Negative 3 squared is 9. Negative 3 times negative 3 is positive 9. Negative 1 times negative 1 is 1. 1 times 1 is 1. And 3 times 3 is 9. As you can see, by squaring it, we end up with a positive number every time. And then the next step is to add up each of those values. These ones add up to 20. And so now we've done this part of our formula. We still need to divide by n minus 1. So n, in this case, is equal to 4 because we have 1, 2, 3, 4 observations. And so we're going to take 1 over 4 minus 1, and we're going to multiply that times our sum, which is 20, and that's going to equal 6.67, or thereabouts. Why do we do this minus 1 here? The reason is because we have a limited number of what we call degrees of freedom. This is a term that will come back later, so I'm just going to mention it now. But the key thing that you need to remember is you need to subtract 1 when you have a sample of data. If you had data for the entire population, then you could just divide by n. You don't have to do n minus 1. But if you have a sample, by the nature of sampling, it introduces this additional error that we need to correct for by subtracting 1 from our number of observations. That's why we do it. So when you calculate the variance, just remember you always want to do the sample variance, which is dividing by n minus 1. So that gives us our answer for the variance, which is 6.67. The trouble with this value is it doesn't really tell us much by itself. It's hard to know what that means. 6.67 what? What are the units on this? the variance is hard to interpret, and so that's why we calculate the standard deviation from the variance.